The poles, they're melting. Scientists say the Arctic has been warming up for years, making the temperature difference between the North Pole and the equator smaller and smaller. The result, warmer oceans fueling extreme weather events.
He's still wearing a woolly hat, but it's no longer really necessary. The ice in Spitsbergen is melting. It's a problem that Norway's most famous polar researcher Kim Holman has long been warning of.
No, we're losing the Arctic as we know it because of climate change. This is a forewarning of all the hardship and problems that will spread around the planet.
As the ground melts, it gives up its secrets. Here, a mammoth skeleton, pulled from the mud in Russia's Arctic, after 10,000 years in the permafrost. Rising temperatures here are delivering riches to some researchers. A complete skeleton is always a valuable find because individual bone fragments basically don't hold any information. Here we know the exact location, the origins of the mammoth, and that it's one specimen. The Arctic touches Russia, Canada, the US and Greenland, but its demise will affect the whole world. Arctic temperatures are rising faster than in the rest of the world, particularly in the last few years. As the differences in temperature between the poles and the equator reduce, the jet stream winds, which move weather around the globe, are slowing down. The result? Extreme weather. High and low pressure systems remain at the same spot for longer, creating floods and droughts. 12 degrees in Spitsbergen might look relaxing, but it's 7 degrees warmer than usual, and that spells disaster.
Well, let's bring in Christina Schadl. She's a research professor at Northern Arizona University. She's also the lead coordinator of the Permafrost Carbon Network, a group set up to address the issue of carbon release from permafrost. Christina, it's good to have you on the show. I want to start with a recent occurrence, tundra fires in Russia. Tell me, what's happening there?
So we have seen increased fire activity in the Arctic over the last years, and in particular this summer. And this is because temperatures are a lot warmer than they usually are, and conditions are really dry, which can enhance wildfires. And increased fire activity is a problem because we've always had fires in the Arctic, and this is nothing new, but right now the fires are much larger, they are more widespread, and they're much more intense. And if fires are really intense, they can burn through the top layer and burn through the organic material, which will then degrade permafrost. And once you have permafrost thawing, that creates a whole other issue and will release a lot of carbon emissions to the atmosphere.
And that's what we're worried about, right?
Exactly. Permafrost is frozen ground that stays frozen for at least 2 consecutive years. And so right now there's condition, as long as it's cold and conditions are frozen, we can keep permafrost the way it is, but with increasing temperatures that changes.
And what's the effect that the release of permafrost carbon? Are we talking about accelerating then global warming?
Exactly. That's what we are doing. And this is why it also why everyone needs to care about this topic and not just the people that actually live in the Arctic. So I personally live in Arizona, which tends to be really hot and dry in the summer.
That's right.
But and then so you might think, why would I care about Arctic temperatures? But increasing temperatures in the Arctic, they cause permafrost to thaw, which will then release more greenhouse gases to the atmosphere. And more greenhouse gases in the atmosphere means we have even more warming, and hence it's really an acceleration of climate change.
What do you say when people say if we do have this warming effect, then that means there's more surface area to plant trees and plants, and those plants then soak up more carbon dioxide. So we've solved the problem.
That would be a very easy solution, which is unfortunately not quite true, and it's really not as easy as you just described it. But we have observed that plants do take up more carbon dioxide and grow better when it's warmer. But carbon dioxide is not warmer temperatures are not the only thing that plants need to grow. They also need nutrients, they need space to grow, etc. And then we're forgetting that plants grow during the summer, but they don't grow during the winter. And microbes are still active in the winter, even if temperatures are below zero. And so if you're looking at the annual carbon budget, you're actually seeing that microbial decomposition releases more greenhouse gases than plants take them up again during the growing season. So right now, it doesn't really look like in the long term plants will totally keep up.
I've got about 30 seconds. I want to ask you, do you have the technology you need to measure carbon release? Because it seems so abstract to the layman.
We have spot locations where we do measure greenhouse gases. What we need is more widespread measurements, longer term measurements, and we need results to be available really quickly so that we can observe on an annual basis where hotspots are.
All right. Christina Shadle from Northern Arizona University. Christina, we appreciate your time and your insights tonight. You're doing valuable work. Thank you.
Thank you.